Let's do the question number 32, which is the analysis of a water sample produces the following results. They have given calcium, magnesium, sodium, potassium chloride, sulfate and bicarbonate. The total hardness of the water sample. See, we know that hardness is created by the multivalent cations. So the only multivalent cations in this question are calcium and magnesium. These two cations are single valency and these are anions. So hardness will be created by calcium and magnesium. Now for calcium 2 plus, they have given the concentration 60 milligram per liter, and its equivalent weight is also given, that is 20. So equivalent weight is equal to 20 milligram per milliequivalent of the ion. Okay, and for Mg2 plus, they have given concentration 36.6 milligram per liter and its equivalent weight is equal to 12.2 given. So if we want to calculate the milli equivalent of calcium and magnesium ions, so milli equivalent of calcium and magnesium ions will be Ca2 plus. Milli equivalent is nothing but we need to divide the concentration by the equivalent weight. So that is 3, and for Mg concentration is 36.3 divided by 12.2. 36.6 is the concentration, so it becomes 3. So total hardness we have to give in terms of milligram per liter as CaCO3. So it will be milligram per liter as CaCO3 will be equal to milliequivalent of calcium plus milliequivalent of magnesium, milliequivalent of calcium plus milliequivalent magnesium, and it will be multiplied by the equivalent weight of CaCO3, that is nothing but, so milliequivalent of calcium 3, this is also 3, into equivalent of CaCO3 is nothing but the atomic weight divided by valency, 100 divided by 2, that is 50. So it becomes 50 into 6 is 300 milligram per liter as CaCO3. So the answer will be 300 is the answer. This question came in GATE 2017 for shift 2. Now the next question is also similar, but they have given the values in milliequivalent per liter directly. See, in previous question, that means in question number 32, we calculated the milliequivalent per liter, that is 3 and 3. Here they have already given milliequivalent per liter, like 2.6 is the 2.65 is the calcium milliequivalent, this value, right? For magnesium it is 4.1 minus 2.65, that is magnesium equivalent. Now I need to calculate the non-carbonate hardness in this question. In previous question we had to calculate total hardness, now we have to calculate non-carbonate hardness. So for non-carbonate hardness, first of all we need to know what is the carbonate hardness, because total hardness is nothing but carbonate hardness plus non-carbonate hardness. And if we want to calculate non-carbonate hardness, we need total hardness as well minus carbonate hardness as well. And carbonate hardness is nothing but the removable hardness, that is from carbonates and bicarbonates. So, or we can say alkalinity or total hardness, whichever is minimum, right? So first of all we need to calculate the total hardness. So total hardness will be equal to calcium milliequivalent. So we know total hardness is nothing but calcium milliequivalent per liter into equivalent weight, just like we did. So calcium milliequivalent is nothing but 2.65. I'll write whatever is given here first and then we will do the question. So for calcium 2 plus, they have given 2.65. So for calcium it is given 2.65 milliequivalent per liter, and magnesium 4.10 minus 2.65 will be equal to 1.45 milliequivalent per liter, right? And sodium also we can just do the minus of 6.35 from 4.1, right? But we don't need sodium and potassium and sulfate and chloride. We don't need that, we just need. And for alkalinity we will be needing SiO3 minus, that will be equal to 3.3 minus 0, 3.3 milliequivalent per liter. Okay, now we can calculate total hardness. Total hardness will be equal to, by the multivalent cations, so calcium is 2.65 and magnesium is 1.45 into 50, right? 2.65 and 1.45 into 50. So if we calculate total hardness, it comes as 205 milligram per liter as CaCO3. Now this total hardness is there in option, 205 milligram per liter as CaCO3. If in hurry we tick on this because we got some answer, then it will be wrong. So for that we need to be cautious before ticking any answer. So this is total hardness. Now we want to know total alkalinity, because I need to check carbonate hardness as well. So total alkalinity will be SiO3 is 3.3, right, into 50, nothing but 165 milligram per liter. Now this is also in option, here option B, but this question is still not completed. Now carbonate hardness will be minimum of total hardness or total alkalinity, right? So it will be, carbonate hardness came as minimum, that is 165 milligram per liter. Now non-carbonate hardness is simple, that is total hardness, which is 205 minus carbonate hardness 165, equal to 40 milligram per liter as CaCO3. So the correct option is option A. This is the answer, right? Okay, let's move on to next question, which is effluent from an industry A has a pH of 4.2. The effluent from another industry B has double the hydroxyl ion concentration than the effluent from industry A. pH of the effluent from the industry will be industry B, they are asking. So let's do the question next. So here the term pH came. pH is nothing but is the measure of the potential of hydrogen ion concentration. So when any substance dissolved in water it dissociates in water either in terms of H plus ion or OH minus ion. That means I am saying that if any substance, so the water will be broken into H plus ion plus OH minus ion. So when any substance dissolves in water, it dissociates in water either in terms of H plus or OH minus ions. And we know that the H plus ion concentration multiplied by OH ion concentration is 10 to the power minus 14 moles per liter. If we take log on both sides, we get log 1 upon H plus ion plus log 1 upon OH minus ion is equal to 14, right? And from this we get, this is nothing but pH. So from this we get that pH plus pOH is equal to 14. This is the main idea behind how pH and pOH comes to be 14. So this is the formula where pH is nothing but log of 1 upon H plus ion concentration. We can simply say minus log of H plus ion concentration, right? And similarly pOH is nothing but log of 1 upon OH minus ion concentration, that is minus log of OH minus concentration. Now this is all about the theory behind the question, right? These are the basic ideas, basic question, we can say the concepts behind the question. Now in this question we have given that the effluent from an industry A has pH of 4.2, effluent from another industry B has the double the hydroxyl ion concentration than the effluent from industry A. So they have simply said that the OH minus of effluent from industry B is 2 times the OH minus of A. So we can simply say OH minus of B is 2 times OH minus of A, right? And they have given the pH of industry A. So pH of, we can say, A is 4.2. Okay, that's good. Now that we know the formula, pH plus pOH is equal to 14. Okay, so pH of A plus pOH plus pOH of A will be equal to 14, right? So by that we can say pOH of A is equal to 14 minus 4.2 and it comes to be 9.8, right? Okay, now this is what pOH. pOH is nothing but minus of log OH ion concentration. Just now we have seen this. Okay, that is nothing but 9.8, right? Now OH minus concentration is nothing but, we can take antilog both side. So it is equal to 1.5898 into 10 to the power minus 10 mole per liter. This pH will come into mole per liter. Now we know that they have already said this thing, that OH minus concentration of B is 2 times OH minus concentration of A, right? So So this is for A. This was for A. So OH of B is equal to 2 times of 1.5898 into 10 to the power minus 10, that is 3.6196 into 10 to the power minus 10. Also, and when we have OH ion concentration, we can simply find the POH, that is log of 1 upon 3.6196 into 10 to the power minus 10. So POH of B comes out to be 9.5. And they are asking about the pH of effluent from the industry B. Simple. Now we have POH of B. So pH of B is nothing but 14 minus 9.5, that is 4.5. This is the answer. So I can simply put out the answer as 4.5. Next is question number 35. A water sample has pH of 9.2. The concentration of hydroxyl ions in the water sample is C. Just now we have done the question number 34. If we have done question number 34, 35 will become easier, right? So let's do this. Concepts are same. So see, let's try question 35. We have given the pH of the sample. pH of any sample is 9.25. And we know pH plus POH is nothing but 14. So POH is 14 minus 9.25. It becomes 4.75. Now we want to know concentration of hydroxyl ion. POH we got. So POH is nothing but log 10 of OH minus concentration, and from here we can simply say that OH minus concentration is nothing but 10 to the power minus POH, right? So it becomes 10 to the power minus 4.75. moles per liter, right? This is OH minus ion concentration. Now this is an option, that is option number B, but first we need to see that it is also in millimoles per liter, not moles per liter, and this is wrong, so this is also wrong. Remaining options are C and D. Let's check. Let's solve it further, and we get moles per liter concentration they are asking. Now the option is in milligram per liter. Milligram per liter, let's change it into milligram per liter. So for milligram per liter, that is nothing but this equals to mole per liter into molecular weight into 10 to the power minus into 10 to the power 3. Molecular weight into 10 to the power 3. This is the thing to change. Milligram per liter is equal to mole per liter into molecular weight to 10 to the power minus 3. 10 to the power minus 4.75 moles per liter. Molecular weight of OH minus ion is 17 to 10 to the power 3. It becomes 0.3028 milligram per liter. So the option is option number C. This is the answer.